This educational video is showing how to conduct an observational study and experiment in statistics. Also, we will show how to see if your experiment is statistically significant. As you can see, this cat is confused about statistics, but soon both you and the cat will understand how to make a proper study and how to understand your findings.
Did you hear about that statistician who went to jail? He had 0 degrees of freedom.
What did the hippie mathematician use for his fire? Natural logs.
This is stats class.
Our observational study is going to compare the mean test scores of people who listen to music while testing and people who don't. We are going to do an experiment testing the same thing, but with the experiment we can actually prove causation and we can perform a z-test because we know sigma, hypothetically.
What an observational study is not in statistics. This is Pascual observing. Observational study is in statistics.
In an observational study, you just compare the results. You don't imply treatment. It's quite like the experiment, but it's not.
This is our observational study. We cannot prove causation with an observational study. And Terry agrees. What an experiment is not in statistics. What an experiment is in statistics.
An experimental study is whenever you grab an SRS of a population and you impose a treatment on it. You control this group and you proves causation for whatever you're trying to study, you see. So for our example, we're studying if music has an effect on how you do in scores. Like on your test. Yeah. Alright, well, it's about time for me to get out of here.
These are the conditions for a z-test.
Alright, so what we've done here is we've put the names, we put the people inside the book bag. We're going to randomize it because that's one of the conditions for an experiment. And what I'm about to do now is I'm going to shake it up. Shake it up really good. Just rub it a little bit. And what this does, it randomizes it, and we're going to pick some people from the population, and those lucky few get to partake in our experiment.
One of the conditions is normality. An n has to be equal to or greater than 30. And since our sample size is 30, it is safe to assume normality in our distribution.
This is our experiment. This is how to find the z-score.
There's 3 different ways to find the z-score. You can A, calculate it, B, ask Mr. Annis, or C, you can hunt it. Come back here. Alright, let's flip this right here over. As you can see, it says Z. It's the z-score. Judging by the size of this one, I'd say she's a 2.576 perhaps. Not too quite sure, maybe 1.96. We'll take it back in and we'll find out what she is.
This is what happens whenever you ask Mr. Renz to find the z-score for you. Hey Mr. Renz, can you help me find the z-score? How to calculate the z-score.
So this is how you calculate the z-score. First, we must follow our favorite inference toolbox. So h sub naught is mu of n minus mu of m equals 0, and h sub a is mu of n minus mu of m is not equal to 0. And we're going to reject at alpha equals 0.01. So the mu of m is that the mean score of people who take the test who do listen to music. And mu of n is the mean score of people who do take the test and don't listen to music. Our n is going to equal 30. And so after we did our experiment, we found that the mean score difference is 8. So then, to solve for this, it's x bar minus the mean over our standard deviation, which we already knew, over the square root of 30. You can't do a z-test unless you know the standard deviation of the population, which we do. So then you do 8 divided by 0.91 to get 8.79, which is practically 0. So then we can reject h sub naught, which was this, at alpha equals 0.01, and conclude that the difference between mean score of people who do listen to music is different than the mean score of people who take the test who don't listen to music.
A word of warning, knowing the standard deviation of the population is unrealistic. Alpha can be set at really any number. 0.05 is most often used, but you can use 0.10, 0.05, 0.01, 0.001, 0.00001, and, well, the list goes on. And Adam agrees. This experiment was statistically significant and alpha equals 0.01. The bloopers.
You doing okay, Ayano?
Yeah.
Good. Your shirt says unicorns.
Yep.
Are not a myth?
Wait a sec. This is Pascual, and this is Pascual observing. That, as you see, was a video camera use fail. This was how many times it took Ayano to say her part.
Okay, so this is how you calculate the z-score. Alright, so this is how you calculate the z-score. First you must get your hypotheses. H sub naught is that mu of n is minus the mu of m. Ah, crap, I said mu of n. Yeah, I
Yeah.
have to do that again. Okay, so first we must...
Wait.
Oh, come on.
Are we doing
You can stop recording now.
It's recording right
Stats will never die.